Welcome to topic number 26. Solution of quadratic equations by completing the square. In the chapter on solution of quadratic equation that we have looked at so far, we solve quadratic equations by factorization and by using the quadratic formula. On this occasion, we are going to use the method of completing the square in order to solve the quadratic equation. Since we have gone through an entire chapter on completing the square just before this one, we will not repeat the process in this one. So we are not going to repeat the process of completing the square in this one. We are just going to be using the expression with the squares already completed. We will solve the equations with the square already completed on the quadratic expressions. It is noteworthy that the quadratic formula can be derived by the method of completing the square. Just like solving any other equation, transposition of formulae should be employed to great effect. Here's our first one, and we are going to write it in the form with the square already completed, right there. So what do? Just like in any other set of circumstances, we are going to get rid of this square, get rid of this positive 5, and we are also going to get rid of this negative 12. Now the one that is least related to the x is the one that we get rid of first, which is this negative 12. So it is going to be transposed to the other side as a positive 12. The next thing that we need to get rid of is this square. Of course, we need to get rid of this and this, but the positive 5 being inside of the bracket with the x is more intimately related to the x. So we're going to get rid of the one that is not so much related to the x. So we need to get rid of this square that we have right there. The opposite of square is square root, so we are going to find the square root of the other side. Right. Do not forget that when the square root exists, it occurs in pairs, a positive and a negative one. So instead of just writing 3.46, we have positive or negative 3.46. And of course, we have x plus 5 is equal to positive or negative 3.46. The 5 is also transposed to the other side. So it is a positive 5, it will become a negative 5 on the other side. Now, we usually put the negative at the back, but because of the convention that we have in solving equations in which we need to include the positive or negative square root, the number that does not have the ambiguity of the positive and negative sign, that one is placed at the front. So we have a negative 5 being at the front. So we're going to do the solutions. The first one is going to be negative 5 minus 3.46 that we have here as negative 8.46. And then we are going to have negative 5 plus 3.46. And this is what we have right there. Negative 1.54. So we may write that as a single answer, only separated by commas. That's what we have right there. Our first example has demonstrated that solving the equation by completing the square is not difficult. At least not after the square has been completed. But we're not going to go through the process of completing the square in topic number 26 because we have done that in topic number 25. Here's another one. And of course, by completing the square, that is what we are going to have. So there are quite a few things that we have to get rid of this time. Need to get rid of this one, negative 25, the square, the negative 3, and the 2. We get rid of the one that is least related, or the one that we call that is furthest away. So we need to get rid of this negative 25. It is going to be transposed to the other side as a positive 25. Then we need to get rid of 2, negative 3, and of course the square that we have right there. Of course the 2 is the least related, so we get rid of it. It is being multiplied here, so we divide on the other side. That's what we have. And of course 25 divided by 2 is 12.5. So we need to get rid of this square that we have here. How do we do that? By finding the square root on the other side. So that's what we have. And as usual, 2 square roots, positive and negative. We have that right there. Now we need to get rid of this negative 3. So we are going to add 3 to the other side. There we go, no problem whatsoever. And then we say 3 minus 3.54, that is negative 0.54, one of our answers. And then 3 plus 3.54, that is 6.54, and we may put those two answers together, only separated by a comma. Another problem on which a square has already been completed, and we are going to transpose and solve our equation. Of course, this negative 49 over 8 is there, so we're going to put it to the other side, transposing as a positive 49 over 8. And of course, we need to do what it takes to get rid of this square, this 5 over 4, and this 2. However, before progressing, we may write all of these fractions as decimal fractions, and that's what we have done right here. So the problem is the same with two exceptions. The fractions are written as decimal fraction, and of course this 49 over 8 is transposed to the other side, so that is why we have the 6.13 on the left and the right hand side. So we're going to be dividing by 2 because we have a 2 here multiplying this bracket, opposite of multiplication, division. So let us divide on the other side. Right. So we're going to divide and we're going to get 3.07. We need to get rid of the square on the left hand side, and that is done by finding the square root that we have done all the time. So there we go. And remember, 2 square roots, 1 positive and 1 negative. And then finally, we're going to add this to the other side. No, it is an addition here. It's a positive, so we're going to subtract on the other side. And that is what we have. So the two solutions are this. The first one is negative 1.25 minus 1.25 minus 1.75, and see what we get. We got a negative 3. And the other one turns out to be 0.5. And that we get by saying negative 1.25 plus 1.75. Now, if we notice, we get a negative 3 here and a 0.5 here. Those numbers are rational. Therefore, we know that this expression that we have here can be factorized. Usually when we get numbers that work out just fine without a lot of horrible looking decimal fractions, we are sure that the figures that we have there, the expression that we have there, can be factorized. So the answer may be written in 1, so just separated by commas, by a comma, and that's all there is to it. Here comes another one. So what do we do? After we have the completed square, we may write it in decimal fractions. And while writing in decimal fractions, what we have done is this. We have taken a negative 1 and we have placed it on the other side where it becomes positive. So these are the adjustments. This expression with a negative 3 is placed on the right hand side where it is placed there as a positive. And of course, we have the decimal equivalent of the fractions. So 4 over 3 is written like this, and 19 over 3 is written like this. So we have on this, it is the right hand side that we have the x on. So we need to transpose everything else to the left hand side. And of course, since we are multiplying by 3 here, we are going to divide by 3 on the other side. And we have done that. Next thing that we need to do is to get rid of this square. So we're going to put the square root on the left hand side. Right there. Then finally, this is going to be transposed to the other side. It may be that we can also reverse the expression. So what we have done, we have placed this on this over here, and then this, we have found the square root of it, and this is what we have. And of course, this is going to be transposed to the other side where it's going to be a negative. So that is our situation. So the solutions are, of course, take this negative 1.3 minus 1.45, and that is what we get. And then, of course, take negative 1.33 and we plus 1.45, and that is what we get. And our two answers are written in one expression like that. So it is a matter of transposing the formula, and that is what we are going to do. Of course, what's there? We have a number that might be subtracted, like this one may be added or subtracted, so we know we're going to take it to the other side doing the opposite. Of course, in this particular case, we are multiplying by something on this side, so we need to divide by that something on the other side. And then we need to do the square root because we have a square. And of course, we need to get rid of this number finally that is inside this bracket. If it is a positive, we're going to subtract on the other side. So it is just straight transpositional formula, and of course, making the minor adjustments with the calculations at the end.